Okay, so good afternoon, everyone, and welcome to this open class for the Certificate in Blockchain Development at York University School of Continuing Studies. My name is Sean Woodhead, and I'm the Program Manager for Blockchain Development, plus a suite of other digital tech programs offered by the school. In my capacity as Program Manager, I oversee the curriculum, instruction, and strategic initiatives for these programs. I've been working in the Ontario higher education system for about 15 years now, and I've been with York University School of Continuing Studies since 2017. On top of my work at York, I'm currently the academic liaison to the Canadian Blockchain Olympiad. As well, I'm currently serving as president for the Ontario Council for University Lifelong Learning. And now on to our instructor. Govind Mohan is a course instructor for CSBC 2000, Introduction to Blockchain Development and Security. And of course, that's part of the certificate in blockchain development. By trade, Govind is a blockchain developer and researcher who has been in the space since 2014. He was involved with several startups and has participated in several hackathons over the years, including winning ETH U of T 2018 and creating a top 10 hack at HackFS 2020. He also is an advisor to legal hackers at U of T Law. So after winning ETH U of T, Gov was reached out to by the Creative Destruction Lab at Rotman Commerce, and they were offering to incubate his group's project at their inaugural blockchain AI stream. So that led to Gov starting DataX Research, which was developing a browser-based blockchain plugin which could facilitate data monetization, along with several other experimental data science projects. He decided to pause DataX and went on to found Virtual Systems, where he currently works as a lead developer. And so you can see that Gov is here with me, and he's going to take us through today's class. So Gov, take it away.
All right, pleasure to be with you guys. And this talk, we're gonna cover the state of blockchain development in 2022. Yeah, so what we will be looking at is mainly the brief history of cryptocurrencies and blockchain, just the general concepts for those that are not quite familiar with them. We're going to look at some of the emergent trends in the space. Specifically, we're going to look at NFTs, not really much about GameFi, but a little touch there, and how NFTs are, involved in GameFi and stablecoins. And we're going to look at what we expect to see in terms of the regulatory horizon. But the focus is going to be on the development side. We're going to look at some smart contract infrastructure. We're going to look at how you can build a Web3 app, what a Web3 app is in the first place. And I hacked out a little NFT minting service for creating 3D NFTs, and we're going to use that as like a little prototype that we can use to see how you can make a blockchain app right now in 2022. All right, so next up. So yeah, I don't think it's worth covering a little bit about me. I think Sean has said a lot about me, but yeah, pretty much I work in a DLT company, a distributed ledger technology company, Virtual Systems, where we're building peer-to-peer systems with advanced networking and ledgering capabilities. Yeah, so how do we get here? This is the latest kind of events in late 2021. There's like MasterCard struck a huge deal with NFT. Don't have to tell you about Facebook. You probably know it as Meta now. It's Axie Infinity is now like employing people. There are people relying on cryptocurrency games as a full-time job. A lot in Asia, a lot in different countries. Jack Dorsey's first ever tweet that I think is one of the biggest events that's kicked off the NFT boom last year. The Bank of Canada is creating a digital cryptocurrency, central bank digital currency. The headline I didn't even get to put here, which happened last week, is India. The government of India is going to transition to a digital currency. They expanded the definition of a cryptocurrency or their banknote to include a digital currency. Very interesting stuff. PayPal is going to launch its own stable coin. All this stuff is going on right now. So how do we get here? I think let's go all the way back. So how did we even get back to the beginning? The concept of blockchain comes from a time-stamping service that was created by researchers Scott Stornetta and Stuart Haber from Bell Labs. Bell Labs at the time, was a hotbed of innovation, and these guys came together and they were trying to solve the problem of immutable documents. There were people who can forge things on a document and claim something as their own when it's not actually their own. They wanted to solve that problem, so they created this time-stamping service where they want to have to create immutable digital records where everyone can see, okay, this is the version of a document, and no matter what, it's going to exist in this form. If people try to tamper with it, they'll have to mess with it in a way that everyone can see. So that way, they'll be outed as corruption or fraud directly. So they started out thinking of a single witness to the timestamp. It's like someone witnesses it or some kind of trusted third party. But whenever you have like a single centralized witness, it's open for subversion or fraud. But then they kind of took this problem, turned it on its head, which is really interesting, because they're like, what if we get a newspaper advertisement in the New York Times? They got a classified ad, and they made the whole world a witness. So they took a set of documents, and they offered this as a commercial service, by the way. So you could get these guys to notarize your document, and the way they did it was they took a digest of the document. It's known as a hash. We'll look at this a little bit later, and they put it out in they put it on in an ad in the New York Times. So that way, it's just gonna be there for the world to see, and everyone can see that, okay, this version of the document is the legit one. So you have a decentralized witness. That's what this is. And they say electronic digital documents are so easy to tamper with, and the change need not leave a telltale sign on the physical medium. These days we have DocuSign and all these different document notarization, where back in the day we just had a signature, right? Anyone can forge a signature, really, if you think about it. There's maybe ways to do it, to detect it, using advanced techniques. But at the end of the day, if someone's really, really skilled at copying a signature, they can get away with it. So they wanted to find a way to timestamp the data itself without any reliance on the characteristics of the medium on which the data appears. So even if you change one bit of the document, it's gonna be completely apparent. It's gonna change the entire thing. So that's where this hash comes in. And it should be impossible to stamp a document with a time and date different from the actual one. So now Satoshi Nakamoto, you guys probably have heard of this. This guy or person or girl, whoever it is. They created Bitcoin in about 2007 to 2008, and the first version was released in 2009 in the public. However, Bitcoin peer-to-peer electronic cash system, the article was released in 2008, and that was the foundation of Bitcoin. That's what created Bitcoin. So he took the concept of the timestamping service from Haber and Stornetta. He cited like 3 of their papers. So, or I keep saying he, by the way, it could be a she, it could be a they. I just want to point that out. Satoshi took the concept of timestamping service and added the novel incentive mechanism for anonymous users to maintain the ledger. Now, what this means is with Haber and Stornetta, they have this company. I don't recall the name. Something starting with S. But you had to basically go to them, and they would put your document in their timestamping service, and they do it for a commercial interest. And Satoshi realized they were like, why not just make this entire thing completely decentralized and anonymous, and anyone can participate. But nobody's going to do anything for free. People are going to want to have some kind of incentive, some kind of revenue, or some kind of monetary compensation for maintaining the ledger, maintaining the ledger of documents. So he invented this incentive mechanism. Again, I say he, I keep catching myself. It's called proof of work. Proof of work is what Satoshi created. Let's look at a little bit of proof of work. So now I mentioned hashes before, cryptographic hashes. The TLDR of a hash is that it's a fingerprint. You can take any document, anything that's in binary, and for a computer, any document is just a bunch of bytes, right? If you have a bunch of bytes, you can basically compress it to a smaller number of bytes which is unique for every single document, and unique in the sense that if you change even one bit, the hash or the fingerprint is going to completely change. And it uses some pretty crazy mathematics to achieve these properties. Because of the crazy mathematics, what happens is that it takes if you were to try to guess the hash of one of these documents, let's take the SHA-1 or I don't know why I put 128 here. This should be 256. Yeah. If you're gonna guess 128 bits, it's gonna take you like 10 to the 13 years. You know, that's gonna take you more time than the history of the universe. 13.7 into 10 to the 9 is the history of the universe, like the age of the universe, as we estimated. So if you were to try to just guess based on random guesses for a fingerprint for a document, it's going to take you. You're just not going to do it. It's just extremely difficult. So what proof of work is a guessing game to guess a simpler version of this like, you know, extremely hard problem. And by that, what that means is you're going to take you want to guess a hash that has just a certain number of zeros in the beginning, and then be able to you want to find a hash that has only like say 6 zeros in the beginning, just by randomly guessing, and your computer is doing this. So that's why Bitcoin takes like, you know, so much GPU power, because you want to just cram as much power as possible to solving or generating as many guesses as possible in real time. And you know, that's what proof of work is. So this way, you know, so the way Satoshi devised it, nobody who is mining Bitcoin, this, if you take part in this proof of work game, it's called mining. Nobody who mines has to actually do any physical work. It's their computer doing all the heavy lifting. They're playing this guessing game of shop. We'll take a look at what this looks like, you know, in a more practical terms in a couple of seconds. But they just leave their computer running to solve these problems, and they are actively maintaining the ledger. So all you have to do is download the Bitcoin software and then run a Bitcoin node, is what it's called, and your node is automatically doing all these things. That's why mining is quite interesting. So I'm gonna show you guys now. Oops. What a block looks like. There you go. Right, so you can see here, the first thing, this is just a random block. I think that it was the most recent block that I saw, 1135. And this block has a certain number of zeros here, 4, 8, let's say something like 16, something like that, zeros in front of the hash. This is a SHA-256 hash, which means it's got 256 bits, and you know, it's going to be represented as bytes here. With this difficulty of the Bitcoin game, you have to guess these many number of zeros, and whoever this node is, F2 pool, they found this hash here, and they've managed to mine this block. Now, what does mining a block actually mean? You have a set of transactions, like I'm going to give you money, A is going to give B money, B like 20 Bitcoin, B is going to give C 30 Bitcoin, and you know, so on. All these transactions are put in a little pool. It's called the mem pool of the Bitcoin. And some of these transactions are randomly selected and put into a block. And you have a whole bunch of these blocks. Each of them has a secret, has to be picked up by a miner, and whichever miner guesses a hash that has these many zeros in front of it, that one wins the game. So there's new Bitcoin that's created in the system, and then that Bitcoin is given fully to the miner, and the block itself is added to the blockchain as the next block. So the blockchain is a sequence of different blocks. Now this comes with its own set of problems, you know, like what happens when two people guess a block at the same time and all that, but that's for a different time. So yeah, just another quick note here is that these pools are these pools are free to join. And if like, you know, if one person, if it's like every person for themselves, it's going to be incredibly hard for anyone to really guess anything or even get anything mined on the Bitcoin blockchain and expect a reward. So typically what happens is you have several different pools where people combine their hashing power. It's called a hash rate, the number of hashes you're able to guess per second. And then if you pull together, and any one person in this pool wins or guesses a new Bitcoin block, the reward will be shared amongst all of them. And over time, the difficulty of guessing a block increases because there's a finite number of Bitcoins. There's a whole lot of different little tiny quirks there in the whole Bitcoin ecosystem that we don't need to get into. It's out of scope of this this discussion. But if you guys turn back to the polls, we can let me get the next poll. I'm curious to hear if any of you guys have done any mining before. Oops. This goes here. Yes. I'll give a couple seconds here. And if you guys can put on chat what kinds of cryptocurrencies you've mined, that would be interesting too, because I'm curious. So it's just probably I'm expecting to see a lot of Bitcoin and Ethereum, maybe a lot of Ethereum these days, because it's the access is higher. Oh, most of you have not. It's not trivial to set up for sure. It's there have been people who made like easier clients to do it, but most people find it hard. Litecoin's a good one. Oh, thanks, Sean. Interesting. So most of you have not. All right. So yeah, let's move on to the next part, which is UTXO. Just give me a second here. I have a lot of things open. Okay, unspent transaction output. So how does the Bitcoin blockchain track transactions, track how much money everyone has? If it were to be like A has 20 Bitcoin and B has 30 Bitcoin, it would just make things a little hard for the value transfer to be captured accurately. So Satoshi devised another pretty clever system, which is unspent transaction output, or UTXO. There's only a finite number of ways, only a few ways that Bitcoin can actually be transferred. So in the beginning, Satoshi was the only miner because they created the entire system. So Satoshi gave people Bitcoin, as maybe they're like, hey, can I buy a pizza? Like this happened later. It wasn't Satoshi that did that. There's transfers that happen from Bitcoin holders to non-Bitcoin holders, and that's one way of transferring Bitcoin. And the other way is that miners receive block rewards in the manner that I described before this. So once this happens, there's new Bitcoin created every block, and then you have transactions from one Bitcoin address to another Bitcoin address. So value moves around in transactions. Now the way Bitcoin creates this really good accounting system, or this really immutable accounting system, is using unspent outputs. So only the unspent outputs are actually tracked. So a transaction output consists of a cryptographic lock and value. You can think of it as each time a new Bitcoin is created, every single piece of it that's transferred to someone else is going to be tracked. So we know a Bitcoin comes into existence only when it's mined. So say I'm a miner and I've just guessed the right hash for a block, and I get 1 Bitcoin. Now, and I say my landlord is grateful enough to accept Bitcoin for rent, and say my rent is half a Bitcoin, and maybe I live in a palace or something. I can send them half a Bitcoin. But if I send them half a Bitcoin, I'm not sending them it's not like 0.5 from Gov to the landlord. It's gonna say from this 1 Bitcoin that was created in this block, I'm basically creating a little creating a new lockbox. That my original 1 Bitcoin is a lockbox which has 1 in it, and then I'm gonna create a new lockbox that takes half of the 1 that was created in this block, and I put that inside the next inside the landlord's set of lockboxes. So the zero 0.5 from my Bitcoin goes to or 0.5 from the Bitcoin that was created in this block, to be more specific, goes to the landlord, and this will happen in the next block, or whichever block is mines this transaction, and that block is going to have its own transactions as well, its own reward. So that block, the next block, is going to introduce its own new Bitcoin into the system. So that's kind of how unspent transaction output works. All right. And here's a little diagram representation of it. So you have transaction here. This 100K Satoshis. Satoshi is just a smaller unit, a denomination of Bitcoin. It's easier to track. Not many people deal in multiples of Bitcoin. So you have, and one Satoshi is 10 to the -8 Bitcoin. And so when you have a new block mined, you have this input here. And then you have multiple outputs that can happen. So you can say out of 100,000, I create one output here, 40,000, and I send it to, in this transaction, to this party here, and then another transaction where I send 50,000, and so on. So that way, this from this Bitcoin that was mined here, there's still 10,000 left in Satoshis, and that can create a new output some other day to some other transaction. I hope that makes sense. If there's any questions, please post them in chat. Now, there's a bit of a transition here. UTXO is interesting because UTXO is a notion of state. And let's talk about Vitalik Buterin here. You probably recognize him at this point. He's the guy who made Ethereum. He was an early supporter of Bitcoin and a prominent community member who realized that the blockchain can support a more general notion of state than UTXO. And he developed Ethereum, which is powered by the Ethereum virtual machine. But we're going to unpack all of this. So let's start with state. So you guys are probably familiar with state and the notion of statefulness and state in like the setting of programming. It's quite common. A program state is a collection of events and interactions during the program's lifecycle that it stores in some retrievable format. In a blockchain, the transaction data that is stored on the ledger is the state of the ledger. I see some questions. Do all cryptocurrencies use UTXO or only Bitcoin? So Bitcoin primarily uses UTXO. Other currencies can use UTXO, but there are others that do not use UTXO. There are, like, in a more general ledger like Ethereum, you can design UTXO you can design a UTXO currency. We'll talk about that in a second. What coins can we mine with an average laptop? Probably one with a low hash rate. So the ones that are that still use proof of work, not Ethereum, not Bitcoin. You're probably not gonna be able to get much with it. But like some of the newer cryptocurrencies. But there are some risks associated with that. Anyway, so getting back to state. So program state is the collection of events and interactions during the program lifecycle. We just talked about that. In a blockchain, the transaction data that is stored on the ledger is the state of the ledger. In the Ethereum white paper, this is the relation that Vitalik himself makes. The state in Bitcoin is the collection of all coins, technically the unspent transaction outputs, or UTXO, that have been mined and not yet spent, with each UTXO having a denomination and an owner. So I have the miner who mines it is the owner, and the denomination is like 1.xyz Bitcoin. That is rewarded to the miner by the system. So now we're going to look at the EVM. The EVM is the Ethereum virtual machine. It's the runtime environment for transaction execution in Ethereum. So you can define and manipulate arbitrary assets known as tokens. That's the interesting part. You can actually change the state of. What this means in Bitcoin terms is I can have a Bitcoin UTXO kind of blockchain on Ethereum. I can have 5 of them at the same time running on Ethereum, and Ethereum just is like, okay, I'll just provide the ledger. You can define whatever you want. You can make Bitcoin 1, Bitcoin 2, Bitcoin 3. You can make something Bitcoin, but with a little twist to it that maybe Bitcoin with infinite coins. I mentioned that Bitcoin as a blockchain has finite coins. You can make a Bitcoin that has infinite coins. You can make a Bitcoin that takes coins away from miners or something like that. If you feel evil like that. What the EVM allows you to do is actually manipulate assets, crypto assets, create new ones, and it just tracks it. It just says here's a ledger and here's a way to program it. You can program the definition of assets using Solidity. You guys probably heard of this one as well. And the code that's used to do this, the Solidity code, is known as a smart contract. So smart contract allows you to transact with the blockchain. So the EVM consists of a stack, a memory, a gas balance. We'll look at that in a sec. Program counter, and a persistent storage for all accounts, including the contract code. So the contract code is actually on the EVM. So when a transaction calls a contract's function, so contract will have several functions. We're going to look at some Solidity now in a second. The arguments in the call are added to the stack, and the EVM translates the contract's bytecode into stack operations. Let's decompose this a little bit more. So yeah, this is a little architectural diagram of what the EVM ecosystem looks like. I'm not going to go into all this stuff, but essentially, just like a computer operates in assembly instructions, right? You have a machine like a laptop that uses x86. If you have a Mac M1, then you probably have the new M1 system. Your Android or your Apple phone has uses an ARM instructions. So it's a whole set of like very low level instructions. So EVM uses opcodes, which are these extremely discrete and like single kinds of operations. And all Solidity code, whatever you write in the Solidity language, when you ask the system to compile it, it's going to become a whole bunch of opcodes. The same as like if you've written a C++ program, for example, when you hit compile using GCC or something, it's going to become a bunch of binary. It's going to become a bunch of machine instructions. Just like that, Solidity code is going to become instructions for the EVM opcodes, and each opcode costs gas to execute. So it's expensive for you to do transactions on the blockchain. The gas cost is determined based on demand on the blockchain, the kinds of opcodes that you use. So some things can be more expensive, and there's also gas costs used for memory, for storage, and putting stuff on the stack, because it's a cost, right? It's a cost because it's a decentralized infrastructure. It's the same concept as using Amazon Web Services. If you're going to put stuff on an S3 bucket, you're going to have to pay money if you're putting a lot of it. So same concept here. And this is why you don't typically store like large files on the blockchain, just because it's going to be really expensive. Let's look at some of these things. Let's start by looking at opcodes. So yeah, as it's actually kind of interesting. They're all these are the official list of opcodes, by the way. This is the opcodes for the EVM. So they are pretty much very similar to these low-level assembly instructions. And Vitalik was inspired by like those kinds of instructions, and he directly ported them over, right? There's a lot of theory that backs this up, and that's what created or led him to develop this. It's like less than, greater than. There are some more abstract or like higher level than opcodes here, like SHA-3, right? Like this isn't something you'd find on an instruction set. And then there are some more blockchain specific ones, like the balance, block hash, and all this. You're never going to find this in an x86 system. Maybe in a future architecture that'll be something pretty cool to look at. Right. So those are opcodes. And now token standards. So now I have the ability to define contracts. That's pretty cool. But okay, so say I'm a developer. I'm trying to I read about Ethereum. I think this is some pretty cool stuff, and I want to build let's say I want to build like a Bitcoin. I want to build like one of those random Bitcoin clones that I mentioned. But then I look into Solidity, and this is like, okay, how do I make a contract? Like I see the spec for the language. How do I know I'm going to make something secure and it's not just going to get hacked? It's all a bit daunting for developers who have ideas for the tech and want to use it. So there's this organization called Open Zeppelin. So they started making token standards for common use cases. If you want to build something like a cryptocurrency like Bitcoin, they have the ERC20 tokens that everyone is probably familiar with them. That's like the most common one. And there's the new ERC they've been around for quite a while. ERC 721, which are NFTs. That's how you define an NFT. In a little bit, we're gonna check out some code that I wrote that defines an ERC 721 token. But yeah, these contracts are have been thoroughly audited for vulnerabilities. So a lot of top security people, go through these contracts and make sure that nothing bad is going to happen. Although it's just at that base level, nothing bad is going to happen. These are contract interfaces. So what you write on the contract or using those standards can have bugs, and those bugs can be exploited. But these standards themselves are just templates. It's like if you guys are familiar with lawyers, or like if you worked with a lawyer before, they have standard templates for NDAs and mergers and things like that, like investment contracts. Like they have like a standard template for it, a rental agreement too, and then you can modify, you can add clauses to it, you can take away clauses. It's the same concept. So it's very interesting in how similar it is to a legal contract. Although of course a smart contract is not legally binding yet. I didn't mean to do that. So how does an organization like Open Zeppelin monetize? So they offer, I think Open Zeppelin specifically, they do, what's it called? They do consulting. So they create these standards. They work with all the top blockchain people to create these standards, and then they do consulting. So they help people build out actual smart contracts. Not many of those blockchain devs out there. So if you guys want to, if you guys get that training, you will see a lot of very interesting opportunities. So yeah, let's check out some of these smart contracts here. So this is the repository. It's all open source. This is the Open Zeppelin / Open Zeppelin contracts. I could throw the link in the chat here if you guys want to check it out. Yeah, so you have the ERC20. Let's start by just looking at that. So .sol is the ERC20 .solidity. .sol is the Solidity extension. And you can see this. You can see what the document actually means, the token standard here. Token standard. There you go. So this is where it says, it gives you a simple summary. So it has it's a standard interface for defining tokens, for the implementation of a standard API for tokens within smart contracts, and basic functionality to transfer tokens and allow tokens to be approved so that it can be spent on by another on-chain third party. So you can have contracts actually call functions from other contracts. And there's all these. This is more of the docs, but let's look at the source itself. So yeah, so you can see it from a language perspective. I would describe it as some kind of a weird combination of C++, Java, and maybe a little bit of JavaScript, a tiny little hint of Python. So it's like a mishmash of different languages. So it's not extremely alien. It's somewhat intuitive, but it still has some very niche concepts that are blockchain related. So it's a little bit of work to understand it. So this is the ERC20. I'm going to ignore these, but this is some kind of inheritance. So it's like kind of object-oriented programming principles. You have balances of the contract. You can have multiple addresses. So say I have 20 people who have I'm going to create a York University coin, for example. And then say Gav, I buy my Bitcoin address buys 20 York University coins, which are pre-minted. I ask this contract to send me some. So then my address goes on here, and then it's a mapping of my address to how much I have, and then if XYZ does it, then it's their address to what they have, and so on. And then you have the name of the contract. It's a string, so it's like York University coin. You have a ticker for it, and then I realize it might be a little small here on my screen. Yeah, you can ask. It's got a lot of these kind of what you would expect, depending on what you can expect. So yeah, so it has like getters for all this stuff. Let's look at an interesting function, which is transfer. It calls a safe transfer function here. So I can say from this, this is the recipient, and this is the amount I want to transfer to someone else. And using the contract, you're able to reference the address that calls the function. So if me, Gav, I call this function, this message sender will be able to infer that I'm calling this, and it'll automatically know my address and the amount of tokens I hold. All these things it'll be able to have access to, and that's just because of all the opcodes that are defined. So that's what you can see here. It doesn't have a sender; it just has a recipient. And you have all these other different functions. I'm not going to go into all of them, but this transfer is pretty much, what the most important thing is. And this is like what you're looking at here. If you think of it in different terms, it's an abstraction of Bitcoin, because you can make a Bitcoin with this. That's a way to think about it. Okay, cool. So now I have another poll question for you guys. Who here has written a smart contract? Oops. So almost everyone here is a no. Well, that's good, because I hope you guys get some skills to start writing smart contracts after this one year, after this presentation. Okay. So let's move on to now that we've seen some token standards, we can start looking at some of the interesting stuff and that you can do with this. So non-fungible tokens, right? I actually didn't show you guys that. Let me get back to non-fungible tokens. Let's quickly check out ERC 721. This website is great. I mean, like, the GitHub is great. Their documentation is amazing for you to actually dive into it, even as someone who probably doesn't have experience with this. So a non-fungible token is a token that you can't really break down. It's fungible means you're able to create denominations. So this makes sense for something like currency. Whereas for digital assets, if you think something like a plushie doll or something like that, or something that it doesn't really make sense to break up into little pieces, like an artwork. You're not going to take a canvas and cut it up into different pieces, right? So you have this one unit. That doesn't mean that multiple people cannot own the same unit, by the way. So you can have fractionalized ownership, but the asset itself is non-fungible. That's how you should think about it. So yeah, this comes with a the most important thing here is just a mint, safe mint. Safe mint, the underscore here is in like Pythonic terms, it's a private function. So you have a token ID here. You don't have transfers. You have just an ID, and then left transfer, and you just have a token ID. It doesn't say like the amount of the token as it did with the ERC20. So that's I hope that makes sense. Yeah, getting back here now. Bored Ape. I don't know if you guys have heard of Bored Ape. It's the funny thing about these cryptocurrencies or these NFTs is that I'm showing you guys these pictures here. Some of these pictures are, I'm not kidding, worth about $1 million. Justin Bieber bought one recently, last week, I think, worth $1 million. So I don't know why they're worth what they are. That's just market forces and out of scope of this. But now we at least know what they are from a technical perspective. So yeah, now I wanna go into a little bit of what building an NFT looks like, what building an actual decentralized application looks like, and what a decentralized application is. Just to be clear, is I have all these smart contracts, but like, how do I interact with them as like in a practical basis, right? I'm a developer. I want to launch a web app, and maybe I want to make like a decentralized Uber. How do I do that? So you have your JavaScript code, your front end code, your back end code. And then normally it's just front end and back end, right? And then you also have your blockchain layer. So you have to think of it as like a 3-part stack. So you're just adding an extra layer to your stack. So I'm going to show you guys the code I wrote to create a decentralized minting service for 3D NFTs. Checking in on the time. Okay, great. All right, so struggling with all my windows. There you go. All right. So this is a service. It's kind of a gimmicky front end. So I'm more of a back end blockchain guy than I am a front end, admittedly. This service allows a user to mint NFTs. And mint 3D NFTs. So I was kind of just a little rant here. I was a little bit, I'm not a fan of the whole 2D NFTs situation because I don't see unique user value. Say if I buy an NFT, I'm buying a picture, and I can't really say I own it. I have like the bragging rights to it, but everyone can see it. Like I put it here in my PowerPoint, right? Like it's these are technically property of other people, but what makes it really property? So I wanted to add like a unique user, something that makes it good, unique to the user. I saw this cryptographer post on Twitter a picture, just a PNG file, and he's like, this is actually a zip file. And I thought that was pretty insane. So I downloaded it. It was a PNG format picture, and then I unzipped it, and it actually worked. So he did a little kind of a little hack with how the PNG format works. So I took that. I'm like, okay, this is perfect. I'm going to add encryption to this, and then make this what I call a hollow NFT, because it's a picture, but it's also like a locker at the same time. And this service allows you to mint it. I made it specifically for 3D files, but it works with any binary, really. I hope my MetaMask has some funds in it. So what I'm going to do real quick is, there you go. Yeah, I'm going to show you guys just quickly how to mint an NFT. Robston is where my, is it Rinkaby? Yeah. So MetaMask is just a browser-based extension, which is a wallet for storing Ethereum. Wrong address. Robson. Well, okay, that's unfortunate. I haven't funded this one here, but so I can't really show you guys the minting part. But what I want to do is show you guys what the NFT itself looks like, and then look at the code. So we're going to see the interesting parts. We're just not going to see MetaMask in action. Yeah. So this app is a decentralized app. You can go check it out on hollowNFT.co. The GitHub description is a bit lacking, but I can add some info on how you can use it. There's a little tour here that shows you how to mint it. Yeah, I mean, you got the tour guide right here, so you don't need the tour. What we're gonna do is take a sample NFT file I've already created. In fact, you can see it on OpenSea. OpenSea is a place where you can put your NFTs, and then people can purchase them. They can make an offer, and they can bid on it. So it's kind of like an auction service. This is the hollow NFT. OpenSea actually just grabs it straight from the contract. So it's only deployed on the Ethereum testnet, but it's still accessible. So I'm just going to quickly show you a hollow NFT I have here. So this is a picture. It's actually this picture here. You can see a lot more here because I was testing. And that's a picture of a hat. And then it's going to ask me for my decryption key. So I'm going to unlock it. And then we can see my NFT is going to pop out. It's just like a 3D hat. I put this together in like a week. So there's a lot that can be done with it. But yeah, that's kind of what the app is itself. So now this is what the app code looks like. I'll put this on chat for you guys to check out. And let's start with what we just saw, the ERC 721 contract. And this is my hollow NFT contract. So you can see it's ERC 721. URI storage basically means that the actual data, as I mentioned to you guys, it's expensive to store data on the blockchain. So you wanna be able to store it on some other service. So I use Filecoin or IPFS for this, which is kind of the recommended standard. And then I have just very few functions. So I let ERC 721 the contract do all the heavy lifting, and all I do is just keep track of how many NFTs are out there, and then I have a price for minting. And then I made a little function so that only I can. There's an only owner keyword that so I can have mint free NFTs by myself because I'm the owner of this contract. And then once an NFT is minted, you have to pay the price. You can do things like check if there's enough Ether to purchase the NFT, and then you can mint the NFT gets minted. And then there's another only owner function, because there's each time an NFT is minted, the Ethereum is stored on the contract itself. So this contract has its own balance. And then what I'm going to do is I created a function that's only owner, so I can withdraw it. So this is like a collections contract, and this is the way I implemented it. So this way I can actually have my own. You can use this kind of format for really creating any collections, any kind of minting service, and you can do this for anything ERC20 as well, if you want to create like a blockchain game or something. And the way this connects with it is you have a set of these scripts. There is the deploy. You have a deploy script, and the deploy script is just going to you're going to compile your contract. And what compile means is it gets converted to those opcodes. I'm going to show those to you. I think the artifacts are there. Yeah, it looks like this. It's a bunch of incomprehensible JSON, but this is just a serialized version of the contract. And once you send this to the Ethereum, any node in the Ethereum blockchain, it's going to there you go, the bytecode. It's going to look at this bytecode, and it's gonna be able to get the opcodes out of it. So this is like kind of the step-by-step deconstruction of how your app can use it. And real quick, because I'm kind of low on time, I'm going to show you guys how you can access it from your dApp. Let's go to routes, JavaScript, Holo NFT. Yeah, so I would put my contract address right here. So this is the address of my contract, my Holo NFT contract. No, it's the smart contract. So once I've deployed it, I deploy it using the deploy script, and then I take the contract address, and then I'm able to call the smart contract functions here. Let me show you guys where that happens. That is here. Yeah, so this is where you're actually calling the mint NFT function. There you go. You can get when you can get the Ethereum service from the window. This is specifically for MetaMask, and then you ask MetaMask, hey, are there any active contracts here? And then MetaMask says yes. If it says yes, then you can start the payment logic. I can get 0.01 Ether, and then once it's mined, it shows you the hash, and then you can have whatever logic you want that continues this transaction. So that's kind of how this whole like blockchain stuff, like a decentralized application, works. Yeah, since I'm happy to answer more questions on chat, but I want to kind of go faster because I got a little bit more content to cover. Stablecoins. So they're a newer asset that has seen rapid popularity, and they achieved their price stability with collateralization, which is some kind of backing in some kind of real asset. And they address some key concerns raised by economists, specifically regarding monetary policy. A lot of economists I talked to, even, they were like, I don't really believe in this whole cryptocurrency thing, because there's no central bank to regulate it or to monitor to regulate the currency. So this is where stablecoins actually come in, because you're saying, hey, I can have my stablecoins be backed by some kind of reserve. I'm gonna fly through these. So there's two kinds of stablecoins: backed and signerage. So backed can be commodity backed, fiat backed, or crypto backed. I'm just gonna quickly go through these. The properties of a backed contract are that you have they're stabilized by assets that fluctuate outside the cryptocurrency space. So cryptocurrencies wildly fluctuate in price. So if you attach it to a real world asset, and you say, I want it to go up when this real world asset goes up, and go down when this real world asset goes down, and then be one-to-one with it, then you're kind of like getting rid of the whole volatility of the crypto markets, and you're able to kind of get past that. And they have a mechanism for redeeming the asset backed by them, and are unlikely to drop below the value of the underlying physical asset because of arbitrage opportunities. And you have commodity-backed cryptocurrency. So you can actually fix your cryptocurrency, and you can build one of these on Ethereum, for example, using Solidity. And that gets you can get real-world data into a smart contract using a service known as oracles. So you can say, give me the gold price, and then I want to create an incentive-based token mechanism so that I have my gold, like let's say Digix. Digix is a gold token. So it's going to reflect the value of gold like 1-to-1 pretty much. So it has to, as used to back the stable coin, and has to reflect the circulating supply of the stable coin. Right. And then you have fiat stable coins, which are like USDT is a very common one, and USDC and DM, formerly known as Libra. They're pretty much the same as the commodity-backed cryptocurrency stablecoins. The key difference is that they're backed to fiat. So they're backed to one or more currencies, most commonly the US dollar, euro, Swiss franc, in a fixed ratio. So Libra, which was Facebook's prior attempt at a cryptocurrency, did exactly this, and it didn't work out for regulatory reasons, so they ended up selling it off. But they had like a little basket of different currencies that they used for it. So the risk with these kinds of currencies is that if you have one single organization that is responsible for maintaining it, like Tether, then it's up to them to be as accountable as possible for saying $1 equals one Tether, one USDT coin, which Tether has been historically a little bit shady about. I'm not saying that they're bad, but they just aren't super transparent about it. As opposed to USDC, which is maintained by this organization known as Center, and they get audited by Grant Thornton like every month. I'm not sure if it's audited, but they get Grant Thornton to like come in and check their finances and put that out in the public every month. So that's kind of a risk associated with these. And crypto, you can have crypto-backed stablecoins. Now these ones are the most interesting ones, like DAI and UST, which is Terra, and wrapped Bitcoin, Haven. So these are collateralized by another cryptocurrency or another or cryptocurrency portfolio, and the peg is executed via on-chain smart contracts. Yeah, so these ones are the most safe ones because smart contracts actually dictate what the incentive flow is. And then yeah, so in many cases you can take out a loan against a smart contract by locking up the collateral and make it worthwhile to pay off the debt should the stablecoin decrease in value. And there's typically a governance token. With DAI, for example, you have the maker token. The maker token is used for a governance. So this is when you have like these flash crashes and like these what the economist Taleb would call black swan events, things that happen like very once in a while but are super high fluctuation. This is kind of like a little demonstration of it. I think I can, yeah, this one's recorded, so if you guys want to check out the picture later, you can, because I'm really running out of time. The last one is Seigniorage. I'm not going to go much into it. It's just algorithmic fluctuation of cryptocurrencies. And what the future holds this year is we're going to see a lot of the regulatory landscape be able to reflect what's going on and be able to take all these changes that are happening and catch up to the technology that's going on here. I think I put some time here for questions and comments, but I think we're running out of time. Here's some of my details here. Yeah.
Just one question that came in, and it ties in with looking towards the future. So there was a question from one attendee. What's going to be the future of the crypto-related job market?
Oh, I think the future is blockchain developers are extremely highly in demand right now. I can tell you that as a fact, because there's not a lot of them that understand this. It's a lot of new technology. And as time progresses, we are only now starting to hit adoption. So we're only now starting to use cryptocurrencies in practice in the real world. So the time is just ripe for getting into this market, in my opinion.
Okay, great. So we are at time. However, we do also have a couple questions remaining. So what I would suggest is perhaps we can officially end the event now and say thank you to all of our attendees for joining us today. And Gav, thank you so much for what was an excellent and engaging open class for those who attended. And I'm thinking right after we finish here, we could perhaps go for those who want to stick around. Gav, do you have a few minutes to, once we finish, then you can respond to those questions as well?
Yeah, for sure. I'd be happy to.
Okay, great. So for those who are in attendance, if you need to leave now, you may do so. And thanks so much for joining us. And then for those who want to stick around for the bonus time, and Gav answering these remaining questions, then you're more than welcome to, of course, stay. So Gav, I'm going to hand it back over to you. Oh, and we have a question about how can we download this webinar. So what we will do is within the next week or so, we're going to tidy up the recording, and then we're going to send a note to all registrants with directions on how they may access the recording. Okay, so Gav, I'm going to hand it back over to you.
Great, thanks, Sean. And thanks everyone for joining before answering these questions. All right, so how can you tell if Bitcoin is authentic when you buy it from an OTC? So Bitcoin transaction is only really valid if you can see it in a Bitcoin Explorer. So I showed this block Explorer earlier. If you have a successful Bitcoin transaction, it should have a transaction ID. You can see these are examples of transaction IDs here, right? So you see these show what the different types of like the values that are created and exchanged between users. So if any exchange doesn't have this information of the transaction hash and all that, then you should be worried, because that's the big point of a Bitcoin, because or blockchain, like perfect accountability. Right, thanks for that. And with the number of cryptocurrencies available now, do you think some of them will be phased out in the future in order for a few of them to be widely adapted payment methods? A good question. I think so. You can't really phase out a cryptocurrency. Because they're decentralized, right? It's if you guys have used torrents before, it's the same concept. It's all peer-to-peer. So as long as there's even like 2 people in the network is still going to be alive. So, but what is going to happen is those are going to die out. We're going to have some standards, and I think the big driver for that is going to be commercial adoption. You have if one of these big organizations like a big tech company, MasterCard partnering with Coinbase to make NFTs, for example, this is going to make certain services more preferred and with more commercial backing, more monetary backing, perhaps more developer support. So those are going to take over, and that's the reason why I don't see Ethereum going anywhere in the near future. So yeah, I don't come from a conci background. Do you ever see a point where not anyone will be with some prior knowledge and code will be able to create a token collections platform easily? It seems like stability, less volatility. Volatility comes from consistency and not so much confusion on which token we should keep an eye out for. Yeah, that's an excellent point about consistency there. But there are already services that allow you to mint NFTs without having no prior knowledge. This is a big focus in the blockchain developer community, and that's a lot of people are creating these apps. And a lot of these hackathons these days, there's still lots of hackathons. I'd urge you guys to check out ETH Global, because they always got these hackathons going. Yeah, the big focus on them is something that allows users to get engaged. Everyone wants people to get engaged in making dApps and making cryptocurrencies adopted, right? Everyone who's in the space. So there's a lot of services out there that do this. Although the one I demonstrated is more like raw if you wanna have full control over your dApp. But there's a lot of these services. Yeah. Is there a central server to store all of Bitcoin? Yeah, so that's what I alluded to before. It's a peer-to-peer network. So it's just like a torrent network. In fact, it even uses the same technology as a torrent network under the hood, which is it's fully peer-to-peer. As long as there are computers, and this is what makes it uncensorable. AWS, Google Cloud Platform, Azure, all of them have downtime. They all go down. They have service outages. Facebook just went down for like a long time, like something recently. But what Bitcoin network has never gone down, Ethereum has never gone down, and that's just because of the decentralized and peer-to-peer nature of the networks.
Awesome. Well, again, Gav, thank you so much for today's lesson, and to all those who attended, thanks so much, and thank you also for sticking around for the bonus time. And on behalf of all of us at the York University School of Continuing Studies, thank you so much, and we look forward to welcoming many of you in the Certificate in Blockchain Development, which starts on February 14th. Okay, take care, everyone. Have a great day. Bye-bye.